Here are the notes for Chapter 2.2a, Derivative Rules, notes on derivative rules. Okay, so first off is the constant rule. If f of x equals c, then f prime of x is equal to 0. So in other words, let's say we had a function, a constant function, or a function that is a constant. Let's say y is equal to 5. Now, if you think about y is equal to 5, this is going to be a horizontal line, and it is going to be going through the y-intercept of 5. And if we want to find the derivative, think of the derivative as the slope finding formula. All right? And if you look at the graph, the slope for a horizontal line is going to be 0. So any horizontal line that is drawn on the graph will always have a slope of 0. So that is why if a function is a constant, then its derivative, its slope, will be 0. There's not going to be any curves. There's not going to be any changes with the graph. It'll be flat throughout, so the slope will be 0 throughout. Okay. We learned the limit definition rule for derivative, and now we're going to be using a much more efficient rule to find the derivative, and that's the power rule. So the rule says if f of x equals x to the nth power, then f prime, the derivative of f of x, is equal to n times x to the n minus 1. So when we start off with x to the nth power, the way we find the derivative rule, the way we find the derivative function, is we take the exponent and we bring it down to the front, and so that's represented by this n times. So bring the n down. So we bring the exponent down in front of the variable, and then we're going to multiply that exponent with the variable in front. And next, we have to just subtract 1 from the original exponent value. So this n is brought down in front, and then the n needs to be subtracted with the value of 1. So n times x to the n minus 1. Okay, so as simple as that. However, there are a couple of important notes that needs to be taken, or that we need to be aware of when we're applying the power rule. We need to be sure that the function is in the appropriate form before applying the power rule. And one thing that we need to do is we need to convert any radicals to rational exponents, okay, first, before applying the power rule. And second, we first need to move all the variables from the denominator to the numerator if necessary. So the power rule is not going to work if the variable is sitting in the denominator. So if it is 1 over x to the nth power, we need to move that x to the numerator before we apply the power rule. Okay, so let's look at some examples. Find the derivative of the following: y equals x to the 7th power. If we apply the power rule, we bring the 7 down to the front, and then we subtract 1 from that exponent. So 7 comes down to the front, 7x. 7 minus 1 is 6, so then we get 7x to the 6th power. Okay. Part B, g of x equals cube root of x. We want to apply the power rule, but we first need to convert the radical to rational exponent. So cube root of x can be rewritten as x to the 1/3. Now we can apply the power rule. We have rational exponents. We have the variable sitting up in the numerator. So the power rule goes like this: bring down the 1/3 in front, 1/3 x. Subtract 1 from the starting exponent. So 1/3 minus 1 is same thing as 1/3 minus 3 over 3. And 1/3 minus 3 over 3 gives us negative 2/3. So we get 1/3 x to the negative 2/3. And now we can clean this up further by getting rid of the negative exponent by bringing the x down to the denominator. So we get 1 over 3x to the 2/3, or 1 over 3 cube root of x squared. Okay, part C, y is equal to 4 over x to the 5th. We have rational exponents. However, we can't apply the power rule yet because this variable is not in the numerator. It's not in the starting, is not in the necessary position in order to apply the power rule. So this x needs to come up to the top. So we rewrite this as 4x to the negative 5. And now we can apply the power rule. So we bring down negative 5 to the front. So bring down the negative 5. The negative 5 will multiply with the 4 to give us negative 20. And then we subtract 1 from negative 5. So negative 5 minus 1 is negative 6. So then we get negative 20x to the negative 6, which is our derivative function. But we can clean this up a little bit more by bringing the negative exponent down to the denominator. So in the end, we do want all negative exponents resolved. But in the beginning, before we apply the power rule, we may need to get the exponent to be negative so that our variable is sitting in the numerator. Okay. For D, we have 8x to the 2/3 minus 5th root of x plus 2 over root x plus 0.875. So with this, we're going to try and rewrite each portion before we apply the power rule. So 8x to the 2/3 is okay, that can stay. 5th root of x, we need to rewrite that as x to the 1/5. And then 2 over root x, we need to do two things. We need to rewrite the root x as x to the 1/2, and we need to bring the x up to the top. So 2x to the negative 1/2. And then the 0.875 is a constant, so we'll leave that alone. Okay, so now we're ready to find the derivative. 8x to the 2/3, we can bring the 8 to the 2/3 in front, and then the 2/3 will multiply with the 8. So 2/3 times 8x to the 2/3. We need to subtract 1 from that starting exponent. So 2/3 minus 3 over 3, and then this will reduce to be 16/3 x to the negative 1/3. Okay, and then finally we bring that down 16 over 3 x to the 1/3. Okay, next variable, x to the 1/5 becomes 1/5 x to the, and then we subtract 1 from the exponent. 1/5 minus 5 over 5. 1/5 minus 1, the same thing as 1/5 minus 5 over 5. Common denominator, and then 1 minus 5 is negative 4. So then we get negative 1/5 x to the negative 4/5, and then that cleans up to be negative 1 over 5 x to the 4/5. Okay, next up, 2x to the negative 1/2. We bring the negative 1/2 in front. Negative 1/2 times 2. And then the exponent, we need to subtract 1 from it. So negative 1/2 minus 1 is the same thing as negative 1/2 minus 2 over 2, which becomes negative 3/2. And then this becomes negative 1. And then we can bring the x down to the denominator to clean this up. Negative 1 over x to the 3/2. Okay, finally, 0.875 is a constant, just like 5 or 4 or pi or 32. Any constant, like what we saw before, this is going to be a horizontal line, and any slope of a horizontal line is going to be 0 because the slope of a straight line will be 0. So that's just going to drop out. So here's our derivative function. A couple more examples. If f of x equals x to the negative 2, find f prime of 2. So this is a two-step process. We first need to find the derivative using the power rule, and then we can plug 2 into the derivative function to find the exact slope, the exact steepness of the curve at that point. So x to the negative 2, this is already set up for us to find to use the power rule. The variable is up in the numerator. We have rational exponents, so we can apply the power rule, bring down the negative 2, subtract 1 from the exponent, so negative 2 minus 1 is negative 3. Clean this up a little bit, negative 2 over x to the cube, x to the third. So here's our derivative function. We just need to evaluate the derivative. So plug 2 into the derivative, we get negative 2 over 2 cubed, which is negative 2 over 8, so negative 1/4. So the slope of the curve at this point will be negative 1 over 4. Okay. Finally, if f of x equals cube root of x squared, write the tangent line equation to the function that x equals 8. Okay, so we need to find the derivative first, find the ordered pair, and then plug the x value into the derivative to find our slope. Once we have our slope and the ordered pair, then we can write the tangent line equation. Okay, so we first need to set this up so that we can get this function in the correct form so we can apply the power rule. We're going to rewrite this as x to the 2/3. So we should be ready to find the derivative. Our variable is already sitting up in the numerator. So first step, we bring the 2/3 down in front. Then we subtract 1 from the exponent. So 2/3 minus 1 is the same thing as 2/3 minus 3/3. And then our derivative function will be 2/3 x to the negative 1/3. Clean this up even further. We get 2/3x to the 1/3. So here's our derivative function. Now we can use this to find our slope. Our target x value is 8. So plug 8 in for x to find the derivative. So f prime of 8 is equal to 2/3 times 8 to the 1/3. We have to evaluate this 8 to the 1/3 first before we multiply with the 3. Order of operations. And the cube root of 8 is simply 2. So 3 times 2 is 6, but then we can cancel out the 2's, so we get 1/3. So our slope is 1/3. We have the x value for the ordered pair, but we still need to find the y value. So we can plug 8 into the original function. And the cube root of 8 squared is simply 4 because we can decrease the value of 8 by taking the cube root first. So cube root of 8 is 2. And finally, 2 squared is 4. So our ordered pair is 8, 4. Our slope is 1/3. Plug into point slope. We get y minus 4 is equal to 1/3 times x minus 8.